All right, so what I want to do now is just talk about the general case of using the method of undetermined coefficients. To make it clear, I'm not going to ask you to do anything like this for an assignment, but some of the problems in the book may be of this general type, and you'll have to do a lot more work to solve them. What I want you to mainly focus on, and the assignments will focus on you solving the kinds of problems from the three basic cases. That way the algebra doesn't get too crazy. And I'm generally going to ask you second order equations. I'm not going to give you higher order equations, but the point is it works for all orders. In this case, we're going to look at a third order equation. We're just going to find the particular solution y sub p, and we're going to use a computer to help us do the algebra. So we have a third order linear differential operator here, and our phi of x is a product of x, which is just a first degree polynomial, an exponential e to the 2x, and a trig function cosine 3x. So again, this idea of these educated guesses that we've been taking applies to this situation too. If we take such a function and look at functions like this with a cosine and then plus another term with a sine and differentiate those, we end up with something similar after we regroup terms. So this, again, the idea is that's where the guess is going to come from. In this case, because x is a first degree, and because there is a trig function present, we have to split it up into two parts. The first part is a first degree polynomial with two coefficients that we don't know, a0 and a1, times our exponential that we see, and times our cosine that we see. But we have to add to that second term, which is a different linear polynomial, first degree polynomial, linear function with two coefficients b0 and b1, and our exponential and our sine. This general format, when differentiated, will look again like this general format. And every time you differentiate it, it will look again like this general format. Because every time you use the product rule, the exponential becomes the exponential, it pulls out a constant. The sines and cosines swap back and forth. Sometimes the sign changes, plus or minus sign changes. And every time you differentiate the constant or the x, you're going to get a 0 or a constant. And then sometimes you're not going to differentiate that. So that's the idea. So again, the point is you take this function, you define this abstract function with these unknown constants, a0, a1, and b0, and b1, and you go ahead and differentiate it 3 times, add to that the first derivative, and you plug it into this equation. By plugging it into this equation, just like we've done before, you're going to group together all the terms that have to be the same on both sides of the equation. And all these terms follow 4 basic steps. So that makes sense because we have, as we've designed it to have 4, we've got exponentials times cosines, we've got exponentials times sines, we've got x times exponential times cosine, and we've got x times exponential times sine. So we plug in our yp into this linear differential operator, and then regroup it in terms of these 4 terms. Each of these 4 terms is going to have a coefficient in front of it, and that coefficient is going to be some formula involving a0, a1, b0, and b1. And each of those we're going to compare to what we see on the right side of the equation, which is this. Since we only have an x times e to the 2x times cosine 3x term, the coefficient for this will be set equal to 0, so that's the first equation. The coefficient for this will be set equal to 0, because we don't see that on the right side. The coefficient of this will be set equal to 1, because we do see a factor of 1 of this on the right side of the equation. And then the coefficient for this will be set equal to 0. So in the end, we're just going to have a system of 4 equations and 4 unknowns. And then we'll have to just solve that, and the computer can do that for us. And that'll give us our solution. Let me just show you what the solution is. Once you do this, and now let me just I'll just show you how you can do this using Maple, which we have on campus. Again, I'm not going to require you to use it, but it is something, if you are familiar with, you can use to do lots of things to simplify, save yourself some time. I'm mainly doing algebra and checking algebra. So I'm going to get out of this and open up. I've already done this. I just want to show you what we're doing. So in this first line, all I'm doing, and this is the code for Maple, I'm defining a function, y, as a function of x. And that's how you do that. And once you do that, you type in what your formula is. Now in Maple, if I want to define subscripts, I use square brackets. So a bracket 0 bracket is the constant a sub 0, and so on. So I've typed in my linear function with the two coefficients times my exponential function times my cosine function. To that, I'm adding another linear function with two coefficients, an exponential, and a sine. And when I evaluated that, it just tells me that this is the function I have defined in more mathematical notation. Next, what I'm going to do is I'm going to plug it into the differential equation, but look what I'm doing. I'm taking the third derivative. In Maple, this is how you would do the third derivative of y. I'm not calling it yp, I'm just calling it y. I'm adding to that the first derivative, subtracting y. And then I'm going to go ahead and subtract the right-hand side of the equation, which is our phi of x. All right? Because this, whatever this is, it should be 0 once we're done determining the coefficients. If we take the equation and move everything to one side, then 0 is on the other side. So because we don't know what these coefficients are, Maple calculates these derivatives because they're based on basic formulas that are programmable. And it does somewhat of a job of organizing it. And there are different ways you can organize things in Maple, but I'm not going to go through that. But what you're getting is, notice that every term has a factor of this e to the 2x. So Maple just factored that out of everything. And we don't really need it because that's never 0 anyways. So if this expression is going to be equal to 0, it has to be that everything inside of these parentheses is equal to 0. And if you look, what do you see? I see a cosine term. I see, and then I see a sine term. And then I see another cosine term. See, they're not all grouped together yet. We have to do that ourselves. Or we can use some more advanced tools in Maple, but I'm not going to do that right now. And then we have this term, which is a cosine term, but it also has an x. Remember, we're ignoring the exponential. We factored it out. And so on and so on. But there's a bunch of terms, but they all fall into one of those 4 categories. So all we have to do is define 4 equations. So what I did is I went through this list and looked for all the terms that had just a cosine of 3x, but no factor of x. And then I just combined all those coefficients. And then I set them equal to 0. Because whatever they combine to be, our right-hand side, because we moved everything to left, is going to be 0. Then I do the same thing for sine. I go through and look for only the terms that have a sine of 3x but no x factor. And then I put that equation in. So I separate it with a comma. And I put that equation in. Again, I'm just putting those coefficients together. And then those have to add to 0. And then I go through and look for the terms that are x times cosine of 3x. In this case, there's 3 because I remember I subtracted that once. There's this plus 1 I have there, which is because we subtracted the phi of x, because that's just representing phi of x that we moved over. And then keep in mind that Maple put a minus out front, so that's why the sign is a plus. And then I do the same thing for sine of x. I go through, find the sine x times sine x terms, which are 2 of them. I combine the coefficients and set that equal to 0. So this is just a system of equations, 4 linear equations with 4 unknowns. And calculators and computers can solve these very easily, especially when there's not that many. And the solutions come out in fraction form, as we see here. So in the next line, all I'm doing is now I'm actually assigning those values of those numbers that we found, and I'm assigning them to those symbols A0, A1, B0, and B1 within Maple, just so Maple now plugs those in. So when now Maple plugs those in and I ask Maple to tell me what y of x is, it's given me the solution with the numbers put in. And to confirm that we got it right, we go back and we can re-execute this line. If I re-execute this line, everything should simplify to be 0 because we took y, the third derivative of y, plus y prime minus y, and then we subtracted phi of x. So this should cancel out to 0 now that we've plugged the numbers in. And we see that it does. It's a little bit smaller. I can make it bigger. So that confirmed that it worked, and this is the solution.